Hello! In my previous video, I talked about solving systems of equation by substitution. In this video, we're going to solve systems of equations, but with a different method, the elimination method. When you're using the elimination method, you want to make sure that you have two terms that are opposites of one another. What I'm talking about is this right here. You have a positive 3y and a negative 3y. Because they're the same size, they're a size of 3y, but they have opposite signs, they qualify as opposites of one another. When you're at this point, you can go ahead and add those two equations together. And what we get is x plus x is 2x. 3y plus a negative 3y or 3y minus 3y cancel out. And we drop that equal sign down. And 5 minus 1 is 4. So we get 2x equals 4. To find out what x is, we need to divide both sides by 2 to get the x by itself, and we get that x is 2. Now that we know what x is, we can take that x and we can plug it into one of the earlier equations. It doesn't matter which one. I'll just do the first one. And what we get is x is 2, so 2 plus 3y, we still don't know what y is, equals 5. We need to get y by itself, so let's take 2 away from both sides. 3y equals 3. We still need to get y by itself, so let's divide that 3 away, and we get y equals 1, because 3 divided by 3 is 1. So what we're left with is x equals 2 and y equals 1. And we can put that into an ordered pair. 2 goes in for our x, 1 goes in for our y, and we have our answer. All right, let's try another example. And in this example, we don't have any perfect opposites, but we do have two terms that we can make opposites pretty easily. Those are 5x and 5x. The only thing we have to do to make one of them the opposite is turn it from a positive to a negative, and then they would cancel out. Now, if I were to do both sides of the equation, and we can pick either one, I'm going to pick the bottom one. But if I multiply both sides by negative 1, I change the sign of the equation without actually changing the equation itself. So I'm going to distribute that negative 1 down here, and I'm going to rewrite the top equation. So our top equation was 5x plus 2y equals 29. And now with our bottom equation, I got to distribute that negative 1. So negative 1 times 5x is negative 5x. Negative 1 times 3y is negative 3y. And we got to bring that equal sign down. And negative 1 times 36 is negative 36. Now I can go ahead and I can add those equations together. So 5x minus 5x, that's just going to cancel. 2y minus 3y, well, that's just going to become a negative y. Got to bring that equal sign down. And 29 minus 36, well, if you're not confident, you can use your calculator for that. But what you would wind up getting is you would wind up getting negative 7. So we get negative y equals negative 7. And all we have to do to get y by itself now is divide both sides by negative 1. And we get y equals 7. So we have our first part of the solution, but we still have to plug it back in to find the other part. I'm just going to use the top equation because that's typically what I do, but if on your problems that you're working, the bottom equation happens to be easier, go ahead and do that. Just you can use the one that's easier whenever you plug it in. But we have 5x plus 2. We said y was 7, so I'm going to put 7 in for y equals 29, just using that top equation there. Well, we know that 2 times 7 is 14, so we can simplify that a bit. And then we need to get that x by itself, so let's take away 14. And we're left with 5x equals 29 minus 14 is just 15. And you can use your calculator if you're in doubt for that. And then we got to divide both sides by 5 to get that x by itself. And we get that x equals 3. 15 divided by 5 is 3. So we have an x is 3 and a y is 7. So the solution then would be 7. Oops, excuse me. Sorry, guys. Whenever we write our ordered pairs, we always write our x first. So the solution then would be 3, 7. With ordered pairs, we always write our x first. So 3 comma 7. There we go. That's it. All right, yet another example where we do not have opposites that we can take away right off the bat. So we're going to have to create those opposites. We have x and 4x. Okay, well, I know that if I multiply 1 by negative 4, I could get the opposite of 4. So that's one. Another thing we have is 2y and 6y. With 2y and 6y, I could multiply the 2y by negative 3, and I'd get the opposite of, well, 6y, right? Since 3 is smaller than 4, I'm going to go ahead and multiply by that. So I'm going to multiply our top by a negative 3, and I'm going to multiply by negative 3, because once I do to one side, I have to do to the other side. Otherwise, it's a different equation. It's not good. And I'm going to rewrite our top after I, of course, distribute that negative 3 there. So negative 3 times x is negative 3x. Negative 3x. Negative 3 times 2y is negative 6y. Got to bring that equal sign over, and 9 times negative 3 is negative 27. All right, then we have to rewrite the bottom equation. So 4x plus 6y equals 30. All right, so now what we have to do is we have a positive 6y and a negative 6y. We can cancel that out. We also have a negative 3x and a positive 4x. Well, negative 3x plus 4x, that's the same thing as 4x minus 3x. That's just 1x. It's just x. Then we got to bring down that equal sign. Negative 27 plus 30, well, that's the same thing as 30 minus 27, which would be 3. So x equals 3. All right, we already got half of our answer. Very nice. Now what I'm going to do is I'm going to go ahead and plug it in, and I'm going to plug it in on top because it's easier in this case. So x is 3. So we got 3 plus 2y, we don't know y yet, equals 9. We got to get y by itself, so subtract 3 from both sides, and we get 2y equals 6. Now we got to divide both sides by 2, and voila, y equals 3. Very nice. So x equals 3, y equals 3, which means that our ordered pair solution is 3, 3. And that is our answer. Right, let's do yet another example. So in this one, we still don't have any opposites, so we're going to need to make them. So we have negative x and negative 5x. We have negative 3y and negative 15y. Well, I notice this negative 1x here. If we multiply that by 5, we would get negative 5x. This negative 3y here, if we multiply that by 5, we get negative 15y. So if we want to make opposites, what we have to do is we have to multiply by negative 5 on both sides. All right, so now that we've done that, let's rewrite our equation after, of course, we distribute. So negative 5 times negative x, that's going to become a positive 5x. Negative 5 times the negative 3y, that's going to become a positive 15y. 2 times the negative 5, that's going to become a negative 10. And then we need to copy down that other equation right below. And now that we have opposites, we can add them up. So we have 5x and negative 5x, those cancel. 15y and negative 15y, those cancel. Negative 10 and 10, those cancel. And all we're left with is 0 on the left side and 0 on the right side. So 0 equals 0. Now, in your expert math opinion, does 0 always equal 0? And the answer is yes, 0 always equals 0. So whenever you get a question like this and the answer is 0 equals 0, 5 equals 5, x equals x, whenever it is the same number equals the same number, what you end up with is you end up with infinitely many solutions. That's your answer. Another way you could report it is same line. So infinitely many solutions is one way. Solutions. And the other way, of course, you could report it is same line, because these are the same line. So anytime you get x equals x, 0 equals 0, infinitely many solutions, or same line. Now, let's say we had gotten, this is just for a hypothetical different question, let's say we had gotten something like 5 equals 7. Well, since 5 never equals 7, if we were to get that, if we were left with something like that, that would be no solution. No solution. But that's not this case. I'm just letting you know what, in a hypothetical world, if we were to get that, that would be our answer. But in this case, it's infinitely many solutions or same line, because we get a statement that says 0 equals 0, it's always a true statement. All right, if you found this video to be helpful, please like it and subscribe. Thank you so much. We got some extra content coming out soon. Stay in touch, stay tuned, and good luck in your studies.